Hi everyone. So in this video, I'm going to show you how to simplify the square root of a negative number. So here you have a square root of negative 4 and you want to simplify this. Okay. So however, okay, it's true you can simplify the square root. We know the square root of 4 is 2. Why? Because 2 times 2 is 4. But the square root of negative 4 cannot be evaluated, cannot be found by using the real numbers. The real numbers as you know of it. Why? Because there's no real number, a real whole number when you multiply by itself, but it will be equal to negative 4. Okay. Some of you may say one note is about negative 2 and positive 2. So like I said, those numbers have to be the same. Okay. They are not the same, so you cannot use the number negative 2 and 2. Okay, some of you may say, what about the real number negative 2 times negative 2? Again, negative 2 times negative 2 multiplied to positive 4. Okay. So, and again, you know that 2 times 2 is also equal to positive 4. So the square root of negative 4, okay, does not exist using the real numbers. So that's why, okay, we can solve the square root of 4, right? That's the negative as the issue right here, okay? So that's a long time ago, I believe in the 18th centuries. So Euler is the one who introduced the concept of imaginary numbers. Why? Because he wanted to give answer to the square root of negative numbers. He wanted the square root of the negative numbers to have the solutions, okay? So after him, I believe was Descartes, who is a French. So Euler is a Swiss mathematician from Swiss, and Descartes is a French and French philosopher as well as a French mathematician from France. So yeah, a little bit of introduction. So how would you solve the square root of negative 4? So let me explain to you how to do this. So you agree with me that negative 4, the radical can be written as negative 1 times 4, right? Again, if I continue further, because you're using the operation of multiplication right here, okay, I can split the single square root in 2. Why? Because we have the operation of multiplication. Does it work with addition or subtraction? No. But if you have a division problem, yes, it works. But it doesn't work with addition, neither with subtraction. Only because you have multiplication. So I can split into square root of negative 1 times square root of 4. Now, so what we agree to do is they create a new set of numbers, okay, which we call the imaginary numbers, right? Why? So that the imaginary number, the square root of a negative number can have a solution, can have an answer. Instead of saying no solution, they wanted to give a solution to a square root of a negative number. So what did they do? Okay, they define the square root of negative 1 to be equal to what number? To I, the imaginary unit I. Okay, so I want you to remember this for life, that the square root of negative 1 is defined to be I. Always true. Okay, and I is equal to the square root of negative 1. So you're going to multiply by, now what is the square root of 4? 4 is a perfect square. Okay, and you know the square root of a perfect square always come rational. So one number do we multiply by itself? You get 4. It's 2. Now mathematicians have agreed for the notation, we don't want to leave the I in front. So you're going to bring the I behind, like you do for 2x. So if you put usually the variable after. Okay, so do the same. So you write the rational number or the factor, the rational factor, and then you write the I next to it. Now, square root of negative 4 is equal to 2i. Okay, so let's move to another example. Check your understanding. Okay, for number 2, what is the square root of negative 9 to be equal to? Please pause the video and solve it. Okay, so let me go over the steps here. The square root of negative 9. So the radical negative 9 can be written as 2 factor of negative 1 times 9. And we know that the square root of negative 9, the negative 1 is I, and the square root of square root of 9 is 3. Why? 3 times 3 is 9. Okay, So you want to find what number what whole number when you multiply by itself, or when you square it, you get 9, it's 3. So the square root of negative 9 is 3i. Again, it is an imaginary number. So we call these imaginary numbers. Why do we call it imaginary? Okay, because the answer, so because that's what mathematician has agreed to call it. Okay, does because they say imaginary doesn't mean it doesn't exist, but we do use complex number or imaginary numbers, like in engineering field, like electrical engineering, and also economists and cell analysts also use imaginary numbers or complex numbers. Okay, so yeah, so this we call that imaginary numbers. And what is the imaginary numbers? Imaginary numbers represent number of the I. Okay, they are basically the answer to the square root of a negative number. Okay, so let's check your understanding with one more. What is the square root of negative 25 equal to? Please pause the video and do this. So this is the final answer. So the square root of negative 25 is 5i. Why? I split the negative 25, the radical is 2, negative 1 and 25. And the square root of negative 1 is I, and the square root of 25 is 5. Why? 5 times 5 is 25. So, and then always one of the rational factor first, and then the I after. Okay? Okay, so let's simplify number 1. So what is the square root of negative 10? Okay, square root of negative 10 can be written as negative 1 times 10. Okay, and I can, because you're using multiplication, so I can split the single root in 2, and the square, you have the square root of negative 1 times the square root of 10. Okay, so the square root of negative 1 is I. So remember, you agree to make it as an I. Okay, and then times the square root of 10. So 10 is not a perfect square. Okay, like one of my students call it the imperfect square. So you want to leave the square root of 10 alone. So if a radical is an imperfect square, or not, if it's an imperfect square or not a perfect square, just leave it alone. So the square root of negative 10 can be simplified as I square root of 10. And always write a notation when you have a square root. We want to put the I in front now. Why? Because I think we don't want you to confuse writing this 10i like this. And so some of you may write, so if you write like this, some of you may think that it's the same as you write where the radical is 10i. So to avoid the misunderstanding, but they're not the same. So to avoid misunderstanding, so make sure you write the I in front. Okay. So we don't think like, okay, the I is either in or out. It's kind of unsure. So to avoid the misunderstanding, write the imaginary unit I in front. Okay. Because some of you may think like I outside and inside is the same thing. They're not the same. So to avoid this, just write the I in front. Okay. So let's continue. So let's do another example for you to check your understanding. What is the square root of negative 15? Okay, please pause the video and solve this. Okay, so the square root of negative 15 is going to be I squared of 15. And again, 15 is not a perfect square. Okay, so you leave it alone. So you leave it at the square root of 15. Okay, so let's try one more time. So what is the square root of negative 7 equal to? Simplify this for me, please. Okay, so the square root of negative 7, sorry, is I square root of 7. Okay, so I hope this video helped you to better understand how to simplify square root of a negative number. Okay, so let's do another set of example. Okay, another kind. Okay, so number 7, how would you simplify the square root of negative 8? Okay, so let me show you. You're going to rewrite negative 8, the square root of negative 8 as, inside the radical, you get negative 1 times 8. Okay, and then you're going to rewrite it as square root of negative 1 times square root of 8. Okay, so now what we know about square root of 8? Okay, 8 can be simplified further. Why? Because 8 can be written as a factor where one of its factor is a perfect square. Okay, so I can rewrite, so it's going to be square root of negative 1 times square root of 4, okay, times square root of 2. Why am I doing this? So 8 can be written as a factor of 4 and 2. Okay, so that's why I can split them in up in 2. Why? Because you are multiplying. And what we know about the square root of negative 1 is I. What about the square root of 4 is 2 times, what is about the square root of 2? Okay, 2 is it's not a perfect square, so leave it alone. The square root of 2, you leave it alone. So the square root of negative 8 is simplified to 2I square root of 2. So let's do another example. Okay, number 8. How would you simplify the square root of negative 18? Okay, I can rewrite negative 18 as negative 1 times 18. Okay. Now I know that 18 can be simplified. I can write 18 as a factor of one in which I can write 18 as using 2 factor, where one of them is a perfect square. So I have square root of negative 1, okay, times what? Times 9, okay, times 3. So I can split that in square root of negative 1 times square root of 9 times square root of 3. Oops, I mean 2. I meant to say 2. Okay, let me fix that first. Sorry for the typo. 9 times 3 is 27. So it should be 2. Okay. So now we know that the square root of negative 1 simplifies to I times the square root of 9 simplifies to 3, and the square root of 2, you leave it alone because 2 is not a perfect square. So I now know that the square root of negative 18 simplified to 3I square root of 2. Okay, so always write the I in between the rational and the irrational factor. Okay, and that's your final answer. So let's try number 9. How would you simplify what about the square root of negative 20 equal to? Okay, and the final answer is 2I, okay, square root of 5. Okay, so I hope this video is helpful. Okay, thank you for watching my video. Have a wonderful day. Bye bye.